Okay, guys. So in today's session, we'll be going with the networking fundamentals. As mentioned, this is going to be the first session in our class. Okay, this is one of the most important prerequisites for cybersecurity. It's very important to understand what IP addresses are and what these various protocols in networking are, and how do devices communicate with each other. Okay, what is DNS protocol? What is DHCP protocol? What are the different categories of IP addresses? What are public IPs? What are private IPs? We cover all that in this networking fundamentals, guys. Again, a lengthy session, so it'll be a lengthy topic as well. So I'll be breaking it down in smaller parts. Okay. So when you talk about networking fundamentals, there are three important definitions to know first. What is networking? What are networks? And what are hosts? When you talk about networking, this is the practice of connecting information devices with each other. Okay. And what I mean by information devices are your personal devices that you regularly see in your day-to-day life. Your mobile phones, your smartwatches, your again smart TVs, your routers, okay, your tabs, okay, or again in organizations you have servers, you have databases, you have firewalls, okay? You have IDS, IPS systems, intrusion detection systems, intrusion prevention systems. So the concept of connecting each of these devices with one another so that they can share the data or resources with one another is the concept of networking. Okay. Now, when you talk about a network specifically, that collection of those interconnected devices is called as a network. Okay, so that group of devices communicating with each other is a network there. Okay, and each of those devices in that network is called as a host. Okay, so exactly the same devices which I listed out earlier: computers, printers, routers, mobile phones, blah blah blah. All of those devices individually are called as hosts. Okay. Now, when you talk about communication between humans, we communicate or address each other with our respective names, our unique names. Okay. Similarly, these devices or hosts also have names. Okay. And that name is called as an IP address, Internet Protocol Address. Okay. So each host on the network has a unique identifier known as an IP address, Internet Protocol Address. And this IP address allows for communication to occur between these devices. Okay. And this IP address has a few important properties to it. Okay. Firstly, this is the IPv4 address we are talking about. So these were developed by the US military in the 1950s or so. And there were multiple versions of it: IPv1, IPv2, IPv3, etc., etc. They didn't properly work out. They didn't successfully work out. What successfully worked out was IPv4, Internet Protocol version 4. And we're still using those addresses in today's world. Okay. And these IPv4 addresses have a few important properties to it. Okay. So firstly, it is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros or ones consecutively. So a bit is the smallest data value a computer can store. Okay. It can either be equal to the value of zero or the value of one. And this language of zeros and ones is commonly known as binary language. By in the sense two digit. Okay. So your IPv4 address is a 32-bit address which consists of 32 zeros and ones. Okay. And this entire 32-bit address again is divided in four equal parts. Okay. So each of those parts is called as an octet. And in each octet, you have 8 bits in total. Okay. And this is what typically that IP address looks like. So each of these octets here, 8 bits is separated by a dot symbol, and you have four octets in total. 8 fours are 32 bits. Okay. And what you see here, as mentioned earlier, is a binary address, guys, numbers and zeros. But we humans actually read another terminology of addresses called decimal addresses. Okay. So what we understand or what we regularly use are decimal numbers. This number 11000000 is actually equal to 192 in human readable language. This number 1010101000 in binary is equal to 168 in our human readable language. So this language is also commonly known as decimal language, numbers which exist from 0 to 9. So now I'm going to show you how do you convert any binary address to a human readable decimal address. Okay. Any questions, any doubts up to this point? Anyone? Akash, Bipin, Guru Datta, Praneet, Rajesh, Shivasai.
No.
Right. Hi, Joseph. Can you hear me? I hope I'm audible, Joseph. We are repeating a few classes, Joseph. There's a couple more students who have joined this session in your batch. Okay, so the first two, three classes might repeat. Okay. But again, we're going to get back on track soon in a couple of days, in 2 days max. Okay. This is going to be a quick recap for you. Right. Moving on, let's talk about how do you convert any binary address into a human readable decimal address. Okay, so let's take this example here: 10101010. There's a binary number here with 8 bits in it. And now we'll talk about how do you convert this number into a human readable number. Okay, so rule number one: to convert any binary number to a human readable number is you write down the values of 2 power 0 all the way up to 2 power 7 from right to left under each bit. So the rightmost bit has 2 power 0 under it. Then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and 2 power 7. So from right to left, under each bit, you have written down these values. Why specifically 2 power everywhere? Because again, this is a binary address. You only have two possibilities. Okay. So now once you have written down these values, step number two is you multiply each power value at the bottom to the upper bit, and you keep on adding it till the end. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Okay, so again, let me write down the values for these numbers first. Okay, anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 120. Okay, so 2 raised to the power 2 is nothing but 2 into 2 times. 2 raised to the power 3 is 2 into 2 into 2, 3 times, that's 8. Okay, so that's how we got these values. Okay. Now, once you have these values here, let's calculate the answer now. 2 power 0 into 0. That's 0 itself. Anything into 0 is 0 itself. 2 power 1 into 1. So 2 power 1 is 2. 2 into 1, that's 2 again. 2 power 2 into 0, 0 again. 2 power 3 into 1, 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. And 2 power 7 into 1, 122. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. Okay. Something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. Okay. So when that exact sequence of frequencies flow through a computer's digital media, it understands it as the number 170. Okay. Is that clear, everyone? Anyone who hasn't understood this and who wants me to repeat it again? Akash, Vipin, Guru Datta, Praneeth, Rajesh, Ravi, Shivasai. Anyone who has a question in this, please do not hesitate, guys. Please let me know. Again, the main objective is you have to understand these concepts very clearly. They're quite important for the upcoming sessions. Okay. So anyone who
I
has a
just
question.
joined.
Oh, Ravi, you've just
Like,
joined. No worries, no
yeah,
worries.
I just
Again, what we're
joined
learning
list.
here is how to convert any binary number to a decimal number. Okay, so there are two simple rules for that, as mentioned a few minutes ago. Rule number one: just write down these values everywhere from 2 power 0 to 2 power 7 under each bit. And then you multiply the lower bit with the top value. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0, and so on and so forth. Okay. So multiply bottom to top and add it to the next value. Okay. So that's how you get the conversion of any binary number to a human readable decimal number. Don't worry, Ravi, just in case if you have missed out anything, all these sessions are being recorded as well. And they will be uploaded on YouTube on the official channel of DurgaSoft. Okay. So you can access them by just searching for cybersecurity classes DurgaSoft and filtering out for the latest videos. And you can get all the content there. Okay. So, excuse me. Yeah, that's about how do you convert any number, guys, from binary to decimal. If you have understood this, I have two other numbers here, and I want you to calculate and give me the answers. If you have a pen and a paper beside you, calculate the decimal equivalent for these numbers: 0 1 0 1 0 1 0 1 and all ones. Okay. These numbers, which I've written down here. Okay. So take your time. If you have a pen and a paper beside you, calculate the answers, the final decimal answer, and give me the values for it. Do we need to learn basic networking? Yes, Bipin. So we'll have to know what IP addresses are, what are the different protocols used in networking, what is TCP, what is UDP, what are, again, DNS servers, what are DHCP servers, what are public IPs, what are private IPs. So all these basic networking concepts are quite important for cybersecurity. Okay. Again, they are included in the course itself. You don't need to learn them from anywhere else. Again, as mentioned, all the prerequisites for cybersecurity are included in this course.
Yeah. First one is 85, I think.
Oh, sorry, I was on mute, guys. Did you get any answers?
Yeah, first one is 85 and second is 255.
Okay, I've got one answer, 85 and 255. Let's wait for the others as well. Okay, I've got one more answer here as 85 and 255, guys. Two answers. Let's just wait for a minute more for the other answers as well. Sorry, wasn't muting. So yeah, got a lot of answers as 85 and 55, guys. Perfect answers. Okay, so the first one is 85 here. Just in case if anyone has got a different answer, again, looking at the logic here, 2 power 0 into 1, that's 1. Plus 2 power 1 into 0, 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0, 2 power 4 into 1, 16, 2 power 5 into 0, 0, 2 power 6 into 1, 64, 2 power 7 into 0, 0. So if you add all that up, 64 plus 16, that's 80, 80 plus 4, 84, 84 plus 1, 85. Okay. And when you put all ones, you just got to add all the numbers. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that gives you the number 255. Now, if anyone has a question, why am I explaining all this? Why do we need this binary to decimal conversion? It's to figure out the range of IP addresses, guys. So if I had to get the first IP, what would I have to do? Just simply put zeros everywhere. And when I put zeros everywhere, first IP simply in decimal is 0 dot 0 dot 0 dot 0. And if I had to get the last IP, the maximum number I can obtain is by putting all ones everywhere. And when I put all ones, I get the number 255.255.255.255. And if someone ever asks you how many IPs are there in total, each bit has two possibilities here. And you have 32 bits in total. So 2 into 2 into 2 into 2 into 2, 32 times. So 2 raised to the power of 32. And that would approximately or close enough give you 4.3 billion IP addresses approximately. Okay. So back then in the year 1950s or so, when IP addresses were invented, 4.3 billion IPs sounded like a large number. But fast forward to 2024 today, population itself is 8 billion people. And each person again has multiple devices again. So 4.3 would have been nowhere sufficient. Okay. That's why these 4.3 billion IPs again are divided in certain categories. Okay. So there's something called as public IPs and private IPs and classes. Class A, class B, class C, class D, and class E, 5 categories. Okay. And in each class again, there's 2 subcategories, public and private, public and private, public and private, and public and public. So class D and class E have no private IPs in them. All of them are public IPs itself. Okay. But before we get into all these categories and all, today we'll talk about the sequence of IPs. So we know what's the first IP, we know what's the last IP. Let's talk about the sequence in between. Okay, how do the IPs progress one after the other? Okay, so there are two simple rules to this, guys. To explain this in a much more elaborative way, let me open up a notepad file here. Okay, so if you, we all know the first IP is 0000. Okay, if I had to get the next IP, rule number 1 is you start incrementing from the rightmost octet. Okay, so the rightmost octet increases by 1. So the next IP is 0001. Next IP 0002. Next IP 03. Next IP 04. Next IP 05. This goes on all the way up to the value 000255. Now, please note, after 000255, you cannot have an IP like 000256. This is not possible. Okay, it's a wrong IP. So once you have reached the maximum number 255, then comes rule number 2. Reset the rightmost octet back to 0, and the left octet increases by 1 now. Okay, so after 000255, next IP would be 0010. Okay, now after 10, don't directly jump to 20. That would be wrong. Remember rule number 1, always increment from the rightmost octet. So after 10, you have 11, then 12, then 13, then 14. Goes all the way up to 1255. Then you have 20. So if you notice, there's a pattern forming here. 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255, and so on and so forth. This goes all the way up to 2550 to 255. Okay. Now, once both these octets are filled, this 0 now changes to 1. And you have the same pattern again from 100 to 10255. Okay. So 00 to 0255 again. 10 to 1255 again. 20 to 2255 again. And then 2550 to 255255. Then this 1 changes to 2. Okay. So this goes on from 200 to 2255255. 300 to 3255255. 400 to 4255255. 500 to 5255255. 600 to 6255255. Like that, the pattern keeps on repeating. And somewhere down the line, you would have 25400, 254, 255, 255, and 25500, 255, 255, 255. Now, whatever repeated all the way from 0000 up to 0255, 255, 255. Same thing again repeats from 1000. So all these cycle back to zeros, and this last zero changes to 1. So now from 1000, this goes all the way up to 1255, 255, 255. Then 2000, all the way up to 2255, 255, 255. 3000, all the way up to 3255, 255, 255. And finally, 255000 up to 255, 255, 255, 255. That's the entire sequence of IPs, guys, from the first one till the last one. And if you keep counting all the IPs, you would get an approximate value of 4.3 billion IP addresses. Okay. And as mentioned again, those 4.3 billion IPs again are divided in multiple categories. Classes, class A, B, C, D, and E. And then two subcategories called public and private IPs. Today, we'll talk about what public and private IPs are. In the next session, we'll talk about these classes as well. Any questions or doubts up to this point? Bipin, Guru Datta, Arun, Praneet, Rajesh. I think Rajesh, you have joined twice. Ravi, Shivasai. Any questions? Does anyone want me to explain anything again?
Yeah, no.
Okay. One second, guys. Some students are joined on the other meeting as well. Any questions, Mahid? Okay. Now let's talk about these different categories. What are public and private IPs? To understand what public and private IPs are, let's take a look at this diagram here. Let's say this is my home network here. And in my home network, I have my own local area network devices. So I have my router, I have my laptop, I have my smartwatch, I have my smartphone, I have my smart TV, whatnot, etc., etc. So these are my private devices, guys. Okay. So any device in this local network is my device, which is in my small local area network here. And these devices collectively form something called an intranet. Okay. So an intranet is your local network. And in an intranet, every single device gets a unique private IP. Okay. So each of these private devices of mine gets a unique private IP here. Something like 192.168.0.1. This is 0.2, this is 0.3, this is 0.4, and 0.5. When they want to communicate with each other, they can address each other or they can talk to each other with these private IPs. Okay. Private IPs are the IPs used in a local intranet to communicate with each other. And when any of these devices needs to communicate with the internet, the external larger network, then we need something called a public IP. So in your house, if you have a Wi-Fi router, that router gets a cable from outside the house, an optical fiber cable or an RJ45 cable or whatever it is. That cable comes from the ISP, Internet Service Provider. In India, we have ISPs like Airtel, Act Fibernet, BSNL, Hathway, etc., etc. So these ISPs have something called public IPs. Whenever you want to communicate with the internet, guys, you need a public IP for that. Okay. So this IP you see here, 1, 2, 3, 4, this is an example of a public IP. So when any of these devices wants to communicate with the internet, with a website like google.com in the internet, they will contact the router first, where the router gets a public IP. And from that public IP, they reach the intended web server. Okay. So to define the public IPs are the IPs globally unique, which are used to identify devices on the internet. They're allocated by the ISPs and they are routable over the internet. And if you want to check what your public IP is, you can go to your browser and in the browser search for what is my IP. Okay. So this is what that IP looks like. Okay. So this is an example of my public IP. And on the other hand, private IPs are the IPs used within private networks, homes, offices, organizations, etc., etc. Okay. They're not directly accessible from the public internet. Okay. They allow devices within the same local network to communicate with each other. Okay. And if you want to check what your private IP is, on the other hand, you open up your command prompt, CMD, and in the command prompt, you search for IP config. Okay. Something like 192.168 0.3. This is my private IP. Now, why am I specifically getting 192.168 here? Why am I specifically getting 49 dot something here? We'll talk about that in the next session. So each of the private IPs and a public IP has a certain range to it, guys. So we'll talk about those ranges in the next session. Okay. So each class has a certain range and each private IP has a certain range in each class. Okay. So we'll talk about all these ranges and I'll show you an easy method to remember these ranges as well in the next session. But yeah, that's that for today's session, guys. What we have talked about today is what is networking, what are networks, what are hosts, and what are specifically IPv4 addresses. What are the properties of an IPv4 address? What is the range of IPv4 address and how did we get that? What is the sequence of IPv4 addresses and what are the categories of them? What are public IPs and what are private IPs? Tomorrow we'll discuss about classes. What are classes? What's class A? What's class B? What's class C? Why are they relevant? Why do we have 5 separate classes? Okay. What's the necessity of them? And what are some important protocols? Okay. What's subnet mask? What is a DHCP server? What's a DNS server? We talk about all this in the next session, guys. In tomorrow's session at the same time. Okay. So yeah, that's that. Nothing further for the session today. And as mentioned, we'll be connecting back tomorrow at the same time. Bye-bye. Have a good day. Oh, before that, any questions or doubts for anyone before we disconnect? Sahu,
Yeah.
Patra. Oh yeah, Sahu, go ahead.
Yeah, actually, these IPs are divided into 5 classes like A, B, C, D, E. So, like, why? Most of the cases, we have like 0 to 255. So, why we need these classes?
We'll talk about that in the next session,
Okay,
Sahu. So it's a
okay.
lengthy topic. So as mentioned, we'll talk about the relevance of classes and what do they mean by class A, class B, class
Yeah.
C. Okay, and their sizes and all. We'll talk about that in the next session. We'll talk about it tomorrow without fail. Okay,
Okay.
right. Any other questions up to what we have discussed until now, guys? In public or private IPs or the range of IPs or public IP to again what are public and private IPs or how to convert any binary number to a decimal number, vice versa. Okay, assuming no questions, we can exit the session here and connect back tomorrow at the same time. Bye bye.